Okay, it sounds like there's been some questions on 12, 14, and 15 from homework 11, so let's do those problems real quick, and hopefully this helps. Number 12 says the ratio of volume of two similar solids is 64 to 729. So I'm going to write out the ratios real quick. So you have length, area, and volume are 1, 2, and 3-dimensional relationships. So length is A to B, length of any one side to the length of another side. Area is A to B squared, and volume is A to B cubed. All right. So what they gave us was the ratio of volumes. So I'm going to write that in the volume spot, 64 to 729. And this is a good question for those of you that emailed me because I don't believe I did one of these in the examples. So my mistake, and good question. All right. Now, they said that the surface area of the largest solid is 567 square kilometers. So I'm going to write that in the denominator of the area spot. And what we're looking for is this spot X here. So basically what we need to do is find this ratio of area. All right, to do that, what we're going to do is take the cube root of both of these things here to get the ratio of length. All right, so we're going to first get this ratio of length, or the similarity ratio it's called. All right, so to cube root that, this is something that I know you guys can do in your calculator as well, but on my calculator it is math, and then there's actually a cube root button here, but you can also hit this X root button, hit any root you want. I'll just use the cube root button here, and then I'm going to enter in alpha y. I can enter this in as a fraction. I mean, you don't necessarily need to do this, but 64 and then divided by 729. So this calculator is the way to go, and this is the calculator you're going to use next year in Algebra 2. But 4/9 is the similarity ratio. All right, so 4/9, there you go. Now, to get this ratio of area, all I need to do is square that. So when I square that, I get 16 over 81. All right, so that is my ratio of area when you square the A over B. And I know that it has to be equal to this ratio. This is the volume, or I'm sorry, the surface area of the larger one. So I can set this proportion equal and find the surface area of the smaller one. All right, all you got to do here is cross multiply. So 81x equals 16 times 567, and divide both sides by 81. I know you guys can handle that part, and you get an answer of 112. And the answer is going to be square kilometers. Okay, the next problem, problem 14. Cone A and cone B are similar. The radius of cone A is 5.4 feet, and the radius of cone B is 16.2. So when we do this length, area, volume stuff, what they gave us here, they gave us A to B. They gave us the similarity ratio. The volume is 5.4 to 16.2. I'm sorry, the length. So what they gave us is a one-dimensional quantity. They told us the radius of cone A is 5.4 divided by the radius of cone B, which is 16.2. So they gave us this similarity ratio. All right. Now, A to B squared then is what we're talking about with surface area. And they told us the surface area of cone A is 43. So first of all, let's get this ratio here, which is 1/3. So if you just do the ratio, you get 0.3 repeating, or turn it into a fraction, you get 1/3. All right, so my ratio is 1/3 for my similarity ratio, my ratio of length. So one is 3 times bigger than the other. That means my surface area is 1 to 9. All right, you just cube that. All right, cube 1, you get 1. Cube 3, you get 9. So basically, I can set that equal to cone A is 43 square feet, and we're looking for the surface area of cone B, which is the larger cone. So that is the proportion that I want to set up, and just cross multiply, and all you get is 9 times 43, which is 172, and that's square feet. All right, and then one more, question 15. Once again, we always do length, area, and volume, and I like to keep this organized, so I like to do, A to B squared, and A to B cubed for each of them. And then I look at what they give me. So the surface area of solid A is, so they're talking about surface area here. We have 675 to 432. I'm going to do the small one at the top and the big one at the bottom. So they gave me a ratio of surface area here. All right. And then they go on to say the volume of solid B is 960. So solid B was the smaller one. So I'm going to put that in the numerator. 960 over, and I'm going to say over X. So I don't know the volume of solid A, which is the larger one. So we did small to big in that order. All right. Now to find my A to B cubed ratio, my volume ratio, I first need to square root this quantity to get my A to B, and then I need to cube it. All right. So first step is to take my square root of, and I can enter in a fraction by doing this alpha y equals, which you guys are going to do next year with this calculator, hopefully quite a bit. So 432 divided by 675, and I get 4/5. All right, so my ratio of length, or my similarity ratio, is 4/5. That makes my ratio of volume then. If I cube that, all I need to do is take this value and just cube it. All right, and I get 64 to 125. So 64 to 125 is my ratio of volume. And I'm staying with small to big. That's important. All right. Now all I need to do is cross multiply. So my solution is going to be 125 times 960 equals X times 64. And just divide both sides by 64. And you get the right answer that you're looking for, which is 1875, and we're talking about cubic meters because we were talking about volume. So yeah, I hope this helps. I mean, obviously you need to write out your length area and volume ratios and fill out what they give you. Feel free to rewind and do what you need to do to figure these problems out. These aren't necessarily that easy, and they were great questions to those of you that emailed me. So I hope you get this figured out, and I hope you guys have a fantastic day.